Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Would you like to learn the beauty of higher engineering and scientific mathematics? Possibly that might be one of the questions that you've been asking yourself. But again, you can have another question. You would like to enjoy the beauty of statistics, but maybe you've been trying different ways and you have never found one which can be fit for you. So today, possibly that you have met with a good news. How are you, everybody who is watching this program? I'm very happy to welcome all international and national viewers who will take advantage onto this program. My name is Olenjolai, Moko TAYAI single. Simply, yes, you can call me Olenjolai. I thank God by His own grace that He has built in. Okay, I thank God by His own grace He has built in me a gift of teaching. So I'll be standing in the positions of a teacher, but that will be possibly the third position that I'll be standing in order to pursue the purpose that we have today. But I thank God by His own grace He has built the gift of. Okay, so another thing, I thank God by His own grace, as I say, that He has built in me a gift of mathematics. I've been teaching mathematics. I love mathematics, and I've been teaching mathematics for so many years. But I thank God by His own grace also He has built in me the gift of engineering. So I'm electronics and telecommunication engineer by profession. So today, I'll be standing in three positions. I'll be standing as a mathematician, I'll be standing as a teacher, I'll be standing as engineer. So, as the subject itself indicates, or the module or the course called probability and statistics, or it's called engineering and scientific mathematics. So actually, this subject you need combinations of teaching, combinations of loving mathematics, and combinations of engineering mindset, because we are teaching engineers and statistics. So when we teach engineers and statistics, actually we are teaching what we call applied mathematics in engineering and science programs. So I would like to take this opportunity to welcome all the national and international viewers into our online undergraduate Polytechnic Institute of Tanzania in square bracket Olenjolai. Simultaneously, I would like to take this opportunity to welcome all our students into our official YouTube channel that's called Online Undergrad Institute of Tanzania in square bracket OLENJOLAIM. What are we doing in these online institutions? First of all, as the name itself indicates, we are doing our business, or we are doing whatever we do, or we are teaching and training our undergraduate students across the entire country of Tanzania and worldwide by using the internet. That's the meanings of the online. Another thing that you have to focus, undergraduate, this is a synonym, or the synonyms of the word undergraduate is bachelor degree. So we'll be focusing, every content that you are going to share with you is just focusing on building the mindset of bachelor students, or students who are doing bachelor degree in engineering and science programs. So you have to understand that. So every content that you're going to find in our official YouTube channel will be building up, or will be doing transformation or transforming your mindset from one level or from one stage to another stage, but with a focus of undergraduate education. So if you're an undergraduate student, then you are in the right and comfortable place where you learn, enjoy, and understand the beauty of mathematics for the rest of your life. Again, another question which you actually can be asking yourself is, how can you access our contents? That's a good question. At this moment, we have our regular students, and we have also new students who have met with our programs in this lecture season. So if it's your first time, I would like to just take or spend at least 1 minute to share with you a few steps that you can register yourself permanently. The first step, you should have an email. In case that you don't have an email, you can open or create a new email online. It means that by using the Google or by using any search engine, actually that you can ask how you can open a new email. The second step, we ask you to sign in YouTube channel, means that to sign in YouTube by using your password and the username. And the third step, we ask you to search, just write, copy and paste this name online, Undegraduate Institute of Tanzania, square bracket OLENJOLAIM, and then you'll see the icons or the welcoming poster. We ask you to click it. Once you click, you'll see our trailer video, means welcoming video, and you'll see also horizontal toolbar which contains homes, videos, playlist, channel, community, and the what and about. So there you are already in our online institution. So again, we didn't register yourself here. We ask you to find the button written subscribe. Click that button. Once you click it, the icons of the bell will appear on your left, on your right hand side, beside the buttons of subscribe. And then the text will change from subscribing to subscribing. So we ask you to click that icons of 40 of the bell. Once you click it, you will see 3 options. Choose the options of all. So from there, you will see a pop-up message from bottom of your screen, and that text actually will tell you that you receive all notification. Why did you register yourself, or why did you subscribe into our official YouTube channel? We have a vision of recording more than 600 videos of high definitions that will be teaching you about different modules or courses for undergraduate students. So in order for you to get notifications whenever we add any new video, because we'll be adding at least 1 video in a day or 1 video in a week. So for you to get notifications is if and only if you have registered. But another thing we want to tell you, in order to benefit from our programs, we ask you to be online. Mean that you have to make sure that at least every day you visit our official YouTube channel to see that there is something new for you. If that's the case, now it's a time for I and you to go inside what I've prepared. So we are in departments of high engineering and scientific mathematics, and we have a modular course called the probability and statistics. And this course, in most of the institutions or colleges or universities in Tanzania, is taught in 2nd year. This is Bachelor in Engineering or Bachelor in Science. And an active, we call it NTA Level 7. So this is because our NTA is Abbreviations of National Technical Award Level 7. And this is chapter 3. In this module, of course, we'll be teaching you 4 chapters. So this is chapter 3 that called Statistical Estimation. And today we are in lecture 6, which is actual new subtopic, very interesting subtopic, but it's not a long subtopic, where we are going to teach about confidence intervals for proportions. So right now, before we start even the session, we ask you to speak that title of the lecture 6. Say confidence interval for proportions. We have told you confidence interval, how you can find a confidence interval about mean, or confidence interval of normal distribution. Confidence interval about mean of the normal population, right? With what? With known noting, with known. With known. So we've been dealing with these formulas in different situations. So we have solved more than 12 examples. So we solved the total of 12 questions. So today I would like to teach you something, or a new concept, which you call it confidence interval for proportions, or interval estimator of population proportion. So let us learn about confidence interval. Confidence interval. Confidence interval for proportion. So for proportion. So in square bracket we have interval. You have interval estimator. You have interval estimator of population proportion. Of proportion, proportion. So this is what we are going to focus today. So you say that if the statistic S is a proportion, of what? Is a proportion of success. Is the proportions of what? Of success. Proportions of success in a sample size. And grown from what? From a binomial. So I'm building this concept of proportions in my mind before we do statistic estimation. Binomial population, which introduced it to you for the first time when you are in ordinary diploma or you are in advanced level. And also it touched a little bit about binomial populations in second chapter, which is called the sampling distribution, in which P is a probability of what? Probability of success, and the Q is a probability of what? Probability of failure. So you have probability of success and probability of failure. So if the statistic S is a proportion of success in a sample size M drawn from a binomial population, in which P is the probability of success and Q is the probability of what? Of failure, then its confidence interval is given as probability of proportion plus or minus standardized value at critical value, then multiplied by some deviation of proportion. I will explain what does it mean. Okay, so we say that you have to listen. Okay, listen. So in proportion, whenever you are dealing with proportion, P, this is stands for probability of success. Probability of 40 of success, which in other words, for this case, we say P will be equivalent to statistical mean. Okay? And then Q, this is stands for what? Probability of what? Probability of failure. In any probability, we have two possible results. An event to succeed, take place, or events to happen, or an event to fail. So you have two possibilities. Either an event to fail. So whenever we have a probability problem, so any problems, we have two expectations. Whether an event to occur, that we call the probability of success, or an event to fail to occur. Right? So for example, if you are doing a research about maybe cigarette smokers, so we're observing a number of people who are smoking cigarettes in particular population. So what do we expect? In case you'll find some people who are smoking we take consideration that the event you're observing has taken place. So that's called probability of success. But in case you find some members of that particular population are not smoking, so we call them non-smokers of the cigarette, that we call probability of failure. So when we say about probability of success and probability of failure, we encounter them in any situations of life, right? So when we deal with what, as I say, that means let me just clarify the concepts of confidence interval for proportions. So simply say that, recall what I've been teaching you for more than 3 lectures, lecture 4, lecture 5, lecture 6. I've been teaching you about this formula, that confidence interval. So confidence interval, confidence limit is equal to statistical mean plus what? Plus or minus some inequality error, if you do remember. So for proportion, remember, for proportion, according to what I've taught you for proportion, this is statistical mean is equal to probability of success. Is equal to probability of what? Of success. And then for proportion again, error, okay, for mean, for estimating what? For statistical estimation, if you do remember, for statistical estimation, or before we say about statistical estimation, so we say that for this case also confidence limit of proportion is equal to what? Probability of success plus or minus error. This is the general formula that you should have to bear in your mind. And this general formula is closely related to a previous formula that we've taught you in the same chapter of statistical estimation. So P stands for probability of 40 of success. All right. So we say that error in proportion, how we define error in proportion. Okay. Error in proportion, we say that this is defined as what? Standardized the value at critical times what? Standard deviation of proportion. Right? So for that case now, we say that, okay, so confidence interval, confidence limit of proportion. Confidence limit of proportion. This is equal to probability of success plus or minus error. So what is error? Standardized the value at critical times what? Standard deviation of proportion. So now, this is also a very important formula. Right? So with these two formulas, it doesn't matter whether it is finite population or infinite population. So you see that even this first, the formula we recalled in this part, we didn't take, because it doesn't matter whether it is finite populations or infinite population, this formula will be applied. Right? So you have to understand, because in some of the questions, you may given an error. So some students, they used to say, in the formula of confidence limit, we don't have any part of error. The issue is, how did you understand? How did you spend time to understand the concept? But this is what we call it in engineering, tolerable error. So what it means of tolerable error? So this is it's an error allowed whenever any scientist or engineer doing such kind of experiment or doing such kind of research. And means of tolerable error. So it means that within that error, if your values or your confidence limit will be within about mean, the confidence limits of about mean will be within the error stated or given, then from there we conclude that your research is valid or your finding is correct. But in case that you generate more error, then from there you can notice that you have caused some errors and what you have found is not correct. So the confidence limit of proportions is equal to probability of success plus or minus the value at critical value times what is standard deviation of 40 of proportion. So from here, from this point now, we can focus on the type of 40 population. How many types of population do you have in statistic? 2. Finite and infinite population. So let us start with infinite population. So remember always infinite population, it's a population whose population size is not 30 known. So infinite population for this lecture or for this module or for this course, remember that this one means that the population size is infinity. That's the meaning we call it infinite population. So the population size is not 30 known. So you say that in a standard deviation of proportion, okay, of what? Of finite, of infinite 30 population. We taught you in chapter 2, this is given as what? This is given as square root of what? Product between probability of success and probability of failure over sample size. So the standard deviation is equal to what? Is equal to the square root of probability of success, the probability of failure over sample size. So if this is equation 1 and this is equation 2, wonderful. So we take that. Second step now. So we say that the next step, we say that now let us substitute what? Equation 2 into equation 1. You should not cram these formulas. Very simple for you to remember them. So you say confidence limit of 40 or of about proportion of 40 infinite for infinite population. For that case is equal to probability of success plus or minus standardized value at critical value, and then multiply by what? Square root of 40 product between probability of success and probability of failure over sample size. So this is another important formula, and you have to remember this formula for the rest of your life. Okay? Noise. So whenever you encounter any problem that will ask you to estimate mean or to estimate proportion, because that or to estimate the confidence interval about proportion for the infinite population, then you have to recall this formula. B, for finite population, this is the population whose population size is known. Finite for finite population. So for finite population, we say that NP is known. NP is known. Okay, for finite population, say that the population size is known. So we say that from what we taught you in chapter 2, the standard deviations for about proportions of finite population is given as what the square root of the product of probability of success and probability of failure over sample size. Then times what the square root of population size minus sample size of what? Population size minus 1. So suppose that this is equation 3. So to find confidence limit, say with me confidence limit, to find confidence limit about proportion, okay, of what? Of finite population, this is equal to what? This is equal to probability of success, because remember that we said that substitute, the process we are doing here, substitute what? Equation 3 into equation 1. So whenever we given any problem, you have to, first of all, this is a technique for most problems in statistics, know the type of population. If you don't know the type of populations, you can do common errors that we don't allow for engineers to do or statistics. So I said this is equal to probability of success plus or minus what? Standardized values at C, then multiply by what? Square root of product of probability of success times probability of failure of what? Of a sample size, then multiply by what? Square root of what? Population size minus what? Sample size over population size minus 1. So this is the general formula that will help you to solve problems on confidence interval about proportion of finite population. So what is this? So it means that after plus or minus, this is what we call the error. And what is this? This is called the error. So the product from the values at C to this point, that's called the error, statistical error. So we have error for this. In most cases, probability of success is given in the problem, but for probability of failure is not given, because you have this formula, you can find it. How? So you have to make the probability of 40 of failure the subject. So minus with probability of success to both sides. So you have Q is equal to 1 minus what it be. So probability of failure, which is Q, is equal to 1 minus P. So remember that this is common. Even if you learn probability and statistics in United States of America, so even a professor or an engineer in the United States of America, if we take considerations of this concept, understand that this expression represents about binomial distributions or about proportion. So these are we call them universal symbols that we use in probability. Because I hear some students say, what if we use A plus B? Yeah, A plus B is equal to 1, but it's not a universal, or it's not a international standard way of doing notation. So remember this expression for the rest of your life, and also remember this expression for the rest of your life. Right? Again, another thing that I want to insist you say that error, because in some questions you'll be asked to find error for finite, error for error of proportion, for infinite population. For infinite population, this is given as what? This is given as square root of what? Probability of success, that's probability of failure over sample size, and then times what? Let's see. What does it mean? Error for proportion is equal to ZC times square root of 40, product of probability of success times probability of failure over sample size. So remember this formula, my dear student. Okay, you can find in most of the books or most of the teachers or lecturers, they used to teach maybe 2 formulas. The ability of a teacher to generate more formulas or a student to generate more formulas depends on their level of understanding. And remember that in case you have different techniques, then you can solve so many problems rather than if you have few techniques. All right? That's the next point. Then if you'll be asked about error of proportion for finite population. So this one, we just deduce it from this formula, error is equal to it. So let's the values at C, multiplied by what? Square root of what? Probability of success times probability of failure over sample size. Again, times what? Square root of what? Population size minus 1, minus what is sample size over population size minus 1. So again, my dear student, remember this formula. Okay? So the last formula that I would like to present for you before we start solving problems about proportion of non-variance of the population, non-variance of population. But here we don't focus about the non-variance of proportions. Simply, before we solve problems about confidence limit about proportions, let me present to you this formula. in some problem, you might be given the sample size and may be given the number of events or the number of what? So the number of success, we can call it. So you have to recall the general formula of probability that we taught you since you were in ordinary secondary education. But if you do remember that we said probability of an event to occur is equal to number of event, used to call it the number of event occurred, number of event occurred over sample size. Very important formula over sample size. So very important formula. Number of event occurred. This we call it successful event or succeeded events over sample size. Very important formula. You'll see it used soon after I give you some problems relating to this. So we taught you probability of an event to occur. So remember the probability of an event. So simply used to call it probability of an event. So we used to say that probability of a certain event to occur is equal to number of event over the number of sample space. Remember this formula. We taught you in ordinary secondary education, but possibly you have thrown it away. But my responsibility to remind you, in case you have forgotten, remember this formula. I know that you danced with it during your ordinary secondary education, and you scored your A, and then from there you say, this is a good one. Wonderful. So are you ready? In case you have any question about what I've taught you, don't hesitate to ask it. Ask in the comment sections of this video. Then I'll try my level best to answer. Even other teachers around the world can answer your questions, or other students can answer your question. So don't hesitate yourself, because the home of Online Undergraduate Polytechnic Institute of Tanzania is the home of understanding. So understanding is one of our priorities. So we like our students to understand, love, enjoy, and get entertainment when they are learning about probability and statistics. So if you have any question, please ask your questions in the comment section, and I will come back or try my level best to answer your question. So let us go into example 13. I believe that now you have so many concepts, and I believe that you have understood what I've been teaching you. So right now, let us test what you have understood. Let us see its application. But this is classroom application. You have to think how you can take this information and apply to solve a real life problem. This is not a real life problem. This is the classroom problem. I want to challenge you. When you are learning this content, think, how can you use this information to solve a real life problem? Because from there, then you'll earn money, right? In classroom learning, you'll earn marks, you'll earn numbers, right? But in real life problems, you'll earn money, or you'll earn something, maybe respect your network or whatever. So this is example 13. Ladies and gentlemen, let me present it to you. And remember that we are using the active learning technique in this program. What does it mean about active learning technique? We don't want our students to be just receiving, just waiting, just following what we are doing. We want our students to challenge themselves, how they can challenge themselves. For example, right now I'm writing example 13. So before I solve example 13, you can pause the video and try to solve example 13 yourself, right? On the rough paper. Once you are done, then you can continue to watch the video and see how I solved it and compare to how you solved it. So from there, you can realize or you can notice the mistake you've done and correct them effectively, and you have to avoid them to do in the next trial of the same problems or related problem. Right? Is that clear for you? Thank you. So out of random sample, my dear student, out of random sample, of 100 students. How many students? 100 students. 100 students at a university. At a university. At a university. Only 82 stated that so 82 stated that they were non-smokers. They were non-smokers. They are non-smokers. Based on this, construct a 99 percent confidence interval. Confidence interval estimate of P. The proportion of all the students at the university who are non-smokers. The proportion of all the students of all students at the university who are non-smokers. And the question is complete. So you can pause the video and copy it. Afterward, you have to read it carefully and understand it. So while you are finishing to copy it, let me clean the blackboard so that you'll be navigating self. So for you to get the concept, you can just follow how I solve the first example for proportion, and then afterward, you can, for the next examples, you can solve or you can try, you can pause the video and try by following the steps that I'm going to follow on solving this problem. So this is it's my advice. Whenever you find a problem about statistics, first of all, you have to understand what does it talk about. Before even you know the type of population, something you have to know. These questions test me about which particular knowledge of statistics. Is this questions about sampling distribution? Is this questions about statistic estimation? Is this questions about hypothesis testing? You have to identify that. Otherwise, you'll be very far from the correct solution of that given problem. So let us read the question slowly. You can read the questions about statistics even more than 3 times before you start to solve it, in order for you to understand. Out of random sample of 100 students at university, 82 stated that they were non-smokers. They are non-smokers. Based on this, constructing a 99% confidence interval, estimate of 40 of P, and P stand for 40, I've told you, the proportions of all students at university who are non-smokers. All right? So the question is not talking about what is statistic estimation. And whenever the technique for you to identify most of the question that talks about TOTI, because in case of the hypothesis, you should find a tested hypothesis. That's the common language. But the technique for you to identify that this problem is about statistical estimation is constructing a certain percent confidence interval. So simply, this is the technique. So this is the only difference between questions about the proportions of sampling distribution and TOTI and the statistical estimation. So this is the keywords that differentiating them. Because we told you about proportions in sampling distributions, right? And then we'll be asking you to find maybe mean, or to find maybe standard deviations and whatever. So this is the difference, right? You have to understand that. So these questions about statistical estimation, again, remember that you should not confuse between the population size and sample size. The question is out of random sample. So we can choose a sample randomly, or you can choose a sample by using different techniques. So this is sample size, it's not population size. But out of this chosen sample, 82 stated were non-smokers. So you can know how many who are smokers. You can know. So remember that when I was teaching you about the concepts of proportions in statistical estimation, I told you that sometimes the sample can be drawn from the either finite or infinite population, and then that sample can be analyzed in more. It means that it can be researched in more. For example here, the sample is being drawn from a certain population, which is infinite because we don't know the population size. But among these 100 students at the university, 82 were non-smokers. So 18 were what? Smokers. So it should not confuse you that this is the population size and this is sample size. That's not true. So that's a trick that always we use to confuse students. Because we know that we taught you two formulas. How you can find confidence limit about proportion for finite population, and how you can find confidence limit about proportions for infinite population. So I would like to repeat again, this is not population size. This is sample size. And this is not sample size. This is what it has been analyzed from the sample size. This is the number of students who are non-smokers. It's not a sample size. The sample is 100. And this sample has been taken from, because after you know that you got the sample which has been drawn, you have to understand again. The question does talk about finite or infinite, because we have two different formulas. So from here, because the population size is not stated, so it is what? Infinite population. Wonderful. Okay, so let us go. I know my students now say, sir, you've been speaking about just right there. We want to see your solution, possibly may be different from the one that we solved. Okay, so solution. So the first thing, we say that identify what? Identify the given data. Identify what is the given data. So identify the given data, we say that first of all we'll be given sample size, which in statistics we use capital N, and this is equal to what? But in some of the books we use the small letter n, it's 100. Again, another piece of information that will be given the number of what? Number of non-smokers, number of non-smoker students is equal to 82. Then for that case, number, we are not given, but we can use, okay. Again, we will be given what? We have to consider confidence level. We'll be given confidence level of what? 99%. What should we find? So we have to construct it. So what's required? We have to find the confidence limit. That the constructions that we have to do. confidence limit, and this confidence limit is not about the mean, about 30, about proportion. So about 30, about proportion. So this is what required, and that is our business. But before you go into the next stage, you have to ask yourself, or you have to analyze the question. Does the question talk about finite populations or infinite? It is what? So it is infinite population. So this is infinite population. So from there, we go into the second stage. So the second stage, we say that we call the general form. Because the general formula, we call the formula of what? Of confidence, of finding confidence limit about proportion, okay, not about anything else but about 30, proportion for infinite 30 population. So I have taught you. So I taught that the confidence limit for this case, its general formula is written as what? Probability of success plus or minus what? Error. And then because it is infinite population, so probability plus or minus the error, it is standardized the value, times square root of what? Probability of success times probability of failure over sample size. So from given formula, from the formula that we have, so yeah, so this is equal to confidence limit. So from the formula that we have there, we know the probability, we don't know the probability of success, we don't know the probability of failure, we don't know the standardized value at critical value, we know just the sample size. How many unknowns do you have? 1, 2, 3, 4. Among the 3 unknowns, among the 4 unknowns that we need to use them in order to compute the confidence limit, we just know only one, which is sample size. We don't know the probability of success, we don't know the probability of failure, we don't know the confidence, what the standardized value at critical value, right? So you go into the steady state. So the steady state, we have to find each what? Each unknown. So we say that in the first state, we say that let us find what? Probability of success. How do we find probability of success? We call the formula I told you. Probability of an event to occur is equal to number of events occurred of what? Number of sample space. You can write in words. So probability of success is what? So this from that formula, you say probability of success, which is P, is equal to, so what the successful event in this problem? Researching or finding the number of non-smokers. What is unsuccessful or failure? Finding the number of smokers students. Right? So successful event, identifying the number of 40 non-smokers among 100 students taken as a sample. And what the failure event? Identifying the number of students who are smokers. Right? That's all. So from there we say the probability of success is equal to what? Number of non-smokers, numbers of non-smokers of what? Sample size. And this sample size is n. Right? So what the number of 40 of non-smokers? It's 82. What the sample size? The sample size is what? 100. So probability of success is equal to 0.82 for probability of success. We go for the first step. The first step, we say that recall. Recall, probability of success plus probability of failure is equal to 1. Then probability of failure is equal to 1 minus probability of success. So this is 1 minus 0.82. And this will make 0.18. So probability of failure is equal to 0.18. So suppose that this is equation 2, suppose that this is equation 3. So what are we still looking for? Just another value at critical value, let's see. So the fifth step. Fifth step, find what? Standardized value, let's see, at what? At 99 confidence interval. So I told you should not claim that ZC corresponding to what? 99% is maybe a certain value. I told you the steps that you have to follow in order for you to find ZC. So if you recall, so refer what I told you in lecture, in lecture 4, in lecture 5, and lecture 2. Okay, lecture 4, in lecture 4 and lecture 5. So just recall. So from there, I told you how you can find that ZC is equal to 2.58. So then C is equal to what? 2.58. So just to refer the technique I taught my students how to find the C. So this is equation 1, this is equation 4. So refer the techniques that I taught you how you can find the standardized value at critical value correspond to 99% in lecture 4 and lecture 5. I taught you TAYAI. I'll let you repeat again. There's no need for an engineering or scientific students to claim that dead C corresponds to 99% is a certain value. No need for you to claim. Because the challenge of claiming the values that I taught you in table or in the given table is sometimes you might be given a confidence level which is not within the given table. So that's why I taught you the best way or the easiest way for you to find it. So, ladies and gentlemen, let me go into the sixth step of solving this problem. And the sixth step, we say that let us substitute equation 2, equation 3, and equation 4 into equation 1. Into equation 1. Okay, so I think that you've got all the information. Okay. So we are looking confidence limit. Zero probability of success, which you found is 0.82 plus or minus. Then we come to the error. What is ZC? It's 2.58. Multiplied by what? Square root of what? Product between probability of success, which is 0.82 times 0.18 divided by sample size, which is 100. So confidence limit about proportion confidence limit of about what? Proportion. This is equal to what? 0.82 plus or minus. So you can use your scientific calculator to compute the error. So take your scientific calculator and let us compute. So you have 0.82 multiplied by 0.18, then over 100, then over square root of the response. Yeah. So the response is 0.03. The response again we have to multiply with 2.58. It's 0.99. So this one is 0.99. That's the confidence limit. Okay, that's the confidence limit. Because the question asks you that we can construct a 99% confidence interval estimate of P, the proportions of all the students at the university who are non-smokers. So therefore, confidence limit of non-smoker students is what? 0.82 plus or minus 0.99. That's the response for example 13. In case you have any question, you can express also the response in percentage, so you should not worry about that. This is plus minus, so I've told you about it. You can write in interval that the first interval, it means that you say 0.82 minus 0. And it's not 0.99, excuse me, it's 0.099. Do this minor correction. This is wrong response. It's not possible for the error to be larger than the actual value. So this is 0.099. But for careless students, they just write it. They don't even spend a minute to think about the fact or the precision of their response. So confidence limit of non-smokers students and backgrounds. Remember also you can write in this way, 0.82 minus 0.099. This is less than or equal to probability of success, and less than or equal to 0.82 plus 0.099. So whatever the way that you write, the response will be correct. Okay? Did you understand? Tell me in the comment sections if you have understood how we solved the given problem. Are you ready for the next example, which will be example 14? Okay. So copy this question and then try it. Okay, example 14. So copy it, pause the video, and try to solve yourself. A sample poll of 100 voters sample poll of 100 voters, sample polls of 100 voters chosen at random from all voters in a given district indicates indicates that 55% of them were in favor. Were in favor of a particular candidate. Find on A 95%, B 99%, C, so you see today, you'll be given a value which is not in the table, 99.73%. Confidence limit. So you can write this question as concept. When you will be doing your revision, you have to be careful for this question, because there are some new skills. Okay. So a sample poll of 100 voters chosen at random from all voters in a given district indicate that 55% of them were in favor of a particular candidate. This is all about election. Find out 95% confidence interval, 99%, 99.73 confidence limit for the proportion of all voters. The proportion of all voters in favor of this candidate. All voters in favor of all candidate. Favor of all candidates. Okay, so as I told you, when you are learning to solve statistical estimation or problems about statistical estimation, as you are learning the topic itself, you might find that these problems are easy. But you have to think that in exam, in a classroom examination, where you'll find more than 10 questions from different topics or from the 4 topics that I've told you. So the best way for you to identify the concept that required to solve every question is having keywords or understanding the keywords of the particular concept, right? And first of all, you have to know whether these questions is talking about a process. Is it talking about statistical estimation? That the question talk about the sampling distributions? That the question talk about normal distribution? So when you follow along my sessions or all my lectures, you will find that yourself, whenever you find a question, even if you fail to solve it, because that's another thing, but you know these questions is talking about what, right? So those are the techniques that I will be developing in your mindset from one lecture to another lecture, so you should not get tired. Okay, so a sample poll of 100 voters chosen at random from all voters in a given district indicate that 55% of them were in favor of a particular candidate. What do you think if it is you? Then, so find 95%, 99%, 99.73% confidence limit for the proportions of all voters in favor of all candidates. So the first difference, or the first keyword that you have to understand that this question is talking about statistic estimation, is the question construct or find, or the questions about confidence limit. In chapter 2 of statistic estimation, of sampling distribution, which we call the sampling and sampling distribution, we taught you about proportion, but we have never mentioned anything about percentage or confidence limit. So the keyword is this, Roman A, Roman B, Roman. Whenever you see this, you have to think the question talks about statistic estimation or hypothesis. That's the first trick. Okay? But again, another challenge, that the question talk about mean or talk about proportion. So the next keyword is this one, for the proportion. Aha! So you have to remember about proportion in statistical estimation. Those are the tricks which I used myself when I was a student of probability and statistics, and I used to implement to my students even in the next level, because for myself maybe I didn't have enough time to practice everything that I was thinking in my mind. All right? So the questions is about statistic estimation. Why? Because of this remaining part. If we eliminate this remaining part, then the questions we can treat it as sample distributions about chaotic proportion. All right? Don't think that it's difficult. If you join me from lecture to lecture, from the first lecture to the last lecture, and then you compile the information, you review this lecture, you watch it several times as well as you can, then you find that this information become yours and become in your subconscious mind. Solution. So remember the technique I told you, which is active learning. You can pause the video and try to solve it yourself on the rough paper, and after you finish, then you can check, you can continue to watch the video and check and correct your mistake yourself before keeping on. Solution. So a sample poll of 100 voters, what does it mean? That's a sample set. So the first step, you say that identify what? Identify the given data. Given data. So the first piece of information that we've been given is what we call the sample size, which is n. So the sample size is, means that in 100 voters, sample size is 100 voters. Okay? Then we say that 100 voters chosen at random from all voters in a given district. And this indicates that 55% of them were in favor of particular candidate. So what are the two events which has been examined by this researcher? He was examining within the sample how many voters who are in favor in particular candidate, and how many voters who are not in favor. So the voters who are in favor in that particular candidate, that we call it in proportions probability of success. And then we say that the number of voters who are in favor in that particular candidate, that's we call it within the number of failures. The number of an event which is not taken place. Right? Good. So you have to understand, because also probably test your level of understanding English. Okay. So we say that so indicate that 55% of them were in favor. So it means that simply we say that, because remember, there's a difference between number and probability. Probability can be expressed in either decimal fractions or in percentage. So in most cases, even this means that the probability of the proportions to lie within the given range. So this is probability, is not the number of voters who are supporting the particular candidate. So simply say that probability of voters support of voters who are in favor of particular candidate, this is equal to probability of success. Probability of 40, probability of success, which you mean P. And this is equal to 55% or 0.55. Right? So what are you given? You'll be given confidence levels. So again, we'll be given confidence level is 95. Then for Roman B, we'll be given confidence level is, this is 95, and this is 99%. Then C will be given the confidence level as what? 99 and 73%. Okay? And the questions it talks about 30. This is infinite population. It's not finite population, it's infinite population. Again, this talks about 30. It is proportion. It is problem of proportion. It's problem of what? Proportion. It's problem of what? Proportion. So it's not talking about maybe mean or whatever. It's talk about proportion. So you have probability of success. So from there you can deduce the probability of failure. So ladies and gentlemen, we go into the second stage. Second stage, say that we call the formula 40 confidence limit. Confidence limit about what? About proportion. This is equal to probability of success plus or minus standardized value at critical value, then square root of probability of success times probability of failure over sample size. Okay? At the confidence limit of a proportion. We know probability of success, we know the sample size, we don't know the probability of failure. So again, we say that you have to recall probability of failure plus probability of success is equal to 1. So probability of failure is equal to 1 minus probability of success. So this will be 100% minus 55%. So this will make 45%. So simply say probability of success, it is 0.55 or 55%, and probability of failure, it is 0.45. Then we say what? So we go for the third state. The third state, let us find in ZC corresponds to what? Corresponds to Roman A, 95%. So I told you the steps. I told you there's no need for you to cram. ZC for this, it's 1.96. So for Roman A, confidence limit. Confidence limit of proportion is equal to probability of success, which is 0.55 or 55%, plus or minus ZC. So ZC, it's 1.96 multiplied by what is square root of 0.55 times 0.45 divided by what? Sample size, which is 100. Okay? So you can use your scientific calculator, and finally, Roman A, we have what? Confidence of what? Confidence limit about what? About proportion is 0.55 plus or minus. When you use your scientific calculator to do your computation, you get 0.097. 0.097. That's the response. So that's the response for Roman A, which is 95%. How about Roman B? Roman B is 99%. So that's your homework. So Roman B, that's your homework 6. So do that homework. Right? So we have Roman C, which is 99.73. So Roman B, remember that this value is not in the, so okay, let us do Roman C quickly. Just I want to help you, because Roman C is 99.73. I know some students are lazy to go quickly about the steps to find the C corresponding to this. So this will make you the first step. So the first step, we say that find ZC corresponds to what? Correspond to 99.73%. So remember that this value or this probability is not in the given table. So you have to remember the steps that we taught you. So you say it's 99.730. So simply this one we say that 99.73%. In other way, this is equal to 0.973. So it's probability in 3 decimal places, in 4 decimal places. So the next step, with the fifth step, we say that sketch it. Sketch the normal distribution. Sketch the normal distribution. So to sketch the normal distribution, So to skip the normal distribution, we say that we have a shaded region and the unshaded. So the total area of unshaded region is 0, so area for unshaded is 0.9973. So to get the area of shaded, the area of shaded is equal to 1 minus 0.0973 over 2. On this side also, so this is area is equal to 1 minus 0.9973 over 2. So you can take your scientific calculator, then take your 1 minus 0.9973 divided by 2. This is 1 point, so it's 0.00135, and also this one is 0.0135. Very important for you to understand. So remember that this is a symmetrical line which dividing the normal curve into two equal parts, right? So the C that you are looking for this case is at this point and also is at this point. So to find the corresponding ZC by using table 4.4, which you should have in your hand, we have to know the probability of unshaded region from here to here, right? Yeah. So it means that this one we write in statistics, mean that we say that this will be the 6th state. We say the probability of 0 less than or equal to Z less than or equal to ZC is equal to what? 0.5 minus 0.00135. So this is equal to what? So 10 minus 5 is 5. Then 9 minus 3 is 6. Then 9 minus 1 is 8. Then 9 minus 9 is what?
0.
No, remember that. Okay, this is the response, so it takes 0.5. Minus the response.
40.
So it is 0.49. 0.49 0.49865. Let me write it clearly. So probability of 0 less than or equal to Z less than or equal to Z is equal to 0.499865. So in table 4.4, probabilities are in 4 decimal places. So let us estimate this. So if you estimate this is 0.4987. So the next state, which is the 7th state, we say that use what? Use table 4.4 to what? To find ZC corresponds. Correspond to what? Correspond to 0.4987. So take your table 4.4. If you forgot it in this session, you have to make sure in the next session you have it. So find the probability of what? So you have to remember that I told you. So we know the probability 0.4987. So find the nearby. The exactly means the same probability in the table or nearby. So 0.49. And then the next number is 8, 0.4987. Wonderful. It is 3.01. So mean that from the bottom. So the C corresponding to that is 3.01. That is a C corresponding to what? Probability of what? 99.73. So we know the ZBC. We go into the eighth step. So the eighth step, we have to. So we say that substitute ZC in equation 1. So equation 1, it's the equation we used in Roman A. To find out confidence limit about proportion is equal to probability of success plus or minus ZC, then square root of probability of success times probability of failure for sample size. Right? So confidence limit is equal to what? Probability of success is what? 0.55 plus ZC, in this case, 3.01. Multiplied by what? Probability of success, it is 0.55 times 0.45 divided by sample size. What the sample size? So 100. Okay? 100. So if that's the case, say that confidence limit is what? 0.55 plus or minus. Use your scientific calculator to compute the response for that case. You will find that it is 0.15. 0.15. That's the response for that. Okay? Is it interesting? So let me know in the comment section if you have understood what we've been doing. So you can see the importance of the concept I told you to find ZC corresponding to the given probability. You should not laze, you have to be hardworking in order for you to master different concepts of statistics. Okay? So, okay, right now, let me give you sample questions of exam. Some past papers, some questions which have been asked in exam. Let me present to you and solve together, then I'll leave the homework for you, additional of homework 6. Because we have to cover this concept in order for, in lecture 7, I will teach you about the confidence interval, about sum and differences. Okay. So, example. So this is example 15. So this example 15 refer what? Refer DIT, Dar es Salaam Institute of Technology. Final exam of what? Write down the question of 2011/2012. And this was question number 1, Roman 2. Simply there we call it Beng 10. So this was question for the Beng 10, so many years ago. So let us read the question. So the question was about the proportion. A survey carried out among 850 are randomly selected from Msasani. This is real Tanzania, or real question talks about Tanzania. Msasani residences. I know Msasani. How about you? Do you know Msasani? If you're an international student, please visit Msasani. 360 were chain smokers. Fine. Two decimal places. A 95% confidence interval. For the population proportion. For the population proportion. Proportion of Msasani residents. Residences who are chain smokers. This was 3 marks. Mashaka is the chatting. Okay, so ladies and gentlemen, you can read the question carefully and then try to see what does the question talk about. It's one of the past paper questions. It's not, but it's been taken from some statistical books. So if you're an international student, you should not get confused that these questions have been asked in DIT final exams. These are the universal books of probability and statistics for undergraduate level. A survey carried out among 850 are randomly selected from Msasani. Just see the author or the lecturer composed this exam, replaced maybe New York and replaced with the word Msasani, or Qatar with the word Msasani, or Tokyo with the word Msasani. So from Msasani residents. Okay, so residents, 360 were chain smokers. Find out to the 2 decimal places and 95% confidence interval for population proportions of Msasani residents who are chain smokers. So you see the trick of the questions there. So at least right now you have the overview, you have the island of what does the questions talk about. Is this population size? That the questions that I want to challenge. It is the sample size that the questions I want to challenge. Now the questions talks about proportions in chapter 2 or chapter 3. Does the question talk about statistic estimation or sampling distribution or sampling theory? So you have to check. So from there, if you've understood example 13, example 14, then even this example 15 is not difficult question for you, right? The issue is you have to be careful and you have to read the question as well as you can. So the question talks about 30 statistic estimation. Why? Because there were 95% confidence interval. That's number one. But statistic estimation contains so many subtopics or so many concepts. Does this question talks about chi-square? Does this question talks about student t distribution? Does this question talks about proportion? Does this question talks about mean for non-variance? Does this question talk about standard deviation for non-variance? The answer is the question talks about proportion. So you have to remember the concepts of proportion. Again, is this the population size? No. A survey carried out among 850 are randomly selected. Always a sample is the one selected. Population is not selected. A sample is the one that has to be selected from the population. A population cannot be selected. So if the population will be selected from what? So you have to understand. So this is the sample size, not the population size. And then among these 850 residences, only 360 were found as chain smokers. So the remaining from this minus this are non-chain smokers. Then you have been asked to construct a confidence interval of 95% for population proportions of Sub-Saharan. Solution. The first stage that I told you always, we say that identify the given information or data. So the first given information that will be given here is sample size. Sample size for this problem is 850. Then I'll be given the number of chain smokers. Number of chain smokers. Why are we given the number of chain smokers? Because this number of chain smokers can help us to find probability of success. So what probability are we going to find? The probability of chain smokers at Msasani residence from the sample taken at Msasani residence. Then we'll be given out, so you have to be careful. So from this number, okay, we'll be given out confidence level. Confidence level. So the confidence level is 95%. And the question talks about 30 proportion. Okay? Those are the given information that we have. Okay? So we go into the second stage. Remember the technique of active learning. You can pause the video and try to solve the questions in the rough paper, and then you come back to check your solution. Second stage. So second stage, we have to recall what the formula. Formula 40, confidence limit. Formula of confidence limit. So the formula of confidence limit for proportion is probability of success plus or minus ZC times what? Square root of product of success, probability of success is probability of failure over sample size. So suppose that this is question 1. So in question 1, we just know the sample size n. We don't know probability of success, we don't know ZC, we don't know probability of failure. So we go to the steady state. Steady state let us find out probability of success. So, which is P. How do you find P? P, this will get from what? Number of chain smokers at Msasani over sample size, which has been selected randomly from Sasani, sample size. This is N. So what the number of chain smokers? It is 360. What the sample size, which has been drawn at Msasani? It is 850. So 0 and 0 cancel. So probability of success is equal to 36 over 85. How about probability of failure? Again, recall. Probability of failure or probability of success plus probability of failure is equal to 1. So to find probability of failure, it is 1 minus probability of success. So this is 1 minus what? 36 over 85. So probability of failure is equal to what? So the LCM is 85. Here we have what? 85 minus 36. So this is 9. You have 7. 7 minus 8 is 4 over 85. So 15. Yeah. So that's the probability of what? Of failure. Then recall the previous steps. The C corresponds, I told you how to find, corresponding to it. To 95% is equal to 1.96. Right? So if you have all of those information, we can substitute them into equation 1 and find the required confidence level. Required confidence limit. So the first step, confidence limit is equal to proportion, probability of success, which it is 36 over 85 plus or minus 1.96, then square root of what? 36 over 85 times what? Times 49 over 85 over square root of 40 of 100. No, square root of 850, which is sample size, right? So use your scientific calculator. In case you lost your scientific calculator, you should not panic. We have our online undergraduate library where we use to equip our students with a very affordable original scientific calculator from Casio. So use your scientific calculator to do the such kind of the computation, and the response you'll find is 0.03939. So 0.039. So therefore, confidence limit of chain smokers at Msasani is 60 over 85 plus or minus. So because the question asked us to find to 2 decimal places, so this is 3 decimal places. So if you approximate, it is 0.04, right? So this is the final response that every engineering and science student is expected gauge. Okay, so I think that you've been enjoying on problem solving. So right now, let me give you, we call it a homework, SNAF. Up to this moment, I believe that you've understood how you can do statistical estimation about proportion, or how you can use confidence level about proportion. So it's a time right now to leave a question for you to practice at your own time. And then you have to join me in the next lecture, which will be lecture 7. So this is homework 6, okay? And this is example 16. Example 16. A survey, and this you have to, okay, a survey of leaks of water pipes in a city. Water distribution. Water distribution system conducted over a representative area. Show that substantial loss occurs in 74 out of 7 pipes tested. Find the 95% confidence limit for the population proportion. For the population proportion of leaking pipes. Leaking pipes in the city. So a survey of leaks of water pipes in a city water distribution system conducted over a representative area show that substantial loss occurs in 74 out of 37 pipes tested. Find the 95% confidence limit for the population proportion of the leaking pipes in the city. Let me read again. A survey of leaks of water pipes in a city water distribution system conducted over a representative area show that substantial loss occurs in 75 out of 37 pipes tested. Find that the 95% confidence limit for the population proportion of the leaking pipes in the city. The questions of proportions or statistics are sometimes very interesting because they are not straightforward. So you have to think. Because, for example, if you check the 34 and 7, sometimes you get confusion that this sentence is not correct, but the sentence is correct mathematically. So, ladies and gentlemen, this is the end of lecture 6. I could have continued and give you more examples as well as I can, but the Holy Spirit is saying that it's enough. So, it's enough. I don't want to overdose you. I invite you to join me in the next lecture, lecture 7. If it's your first time or you join me in the middle of this lecture, this is Olenjolai from Tanzania. I'm here to teach you about the beauty of higher engineering and scientific mathematics. And today we are in departments of higher engineering and scientific mathematics. And the module of the course is called Probability and Statistics. This is the one of the module being taught at the Dar es Salaam Institute of Technology under the curriculums and the syllabus of National Council for Technical Education, or in bracket NAT. So if you're students of the Dar es Salaam Institute of Technology, you're in second year, this is the right information for you that can help you to just to fly in mastering probability and statistics. So if it's your first time or you join me in the middle of this lecture, or you have been, or just you join me within a few minutes, remember to subscribe onto our official YouTube channel for you to get notification whenever we upload or we publish a new lecture. Invite your friends. Keep enjoying the beauty of probability and statistics. Let us meet in lecture 7 when I will teach you about confidence interval of sums and differences. And I will refer some concepts that I taught you in lecture 5 and lecture 4. But I refer some concepts that I taught you in the chapter 2 that called sampling theorem, or sampling theorem, or sampling theory, whatever the case that you can call it. But proportions, when I taught about confidence interval are for proportions, and confidence interval for sums and differences of normal distribution or normal population. These are not insisted parts or concept in most of the institutions, colleges, or universities. But you can find its questions in so many exams. So you should be well prepared and master them before you make them in exam. So in case you have any question about lecture 5, lecture 6, don't hesitate to ask in the comment section and I will answer your questions. But use the comment section also to give us feedback whether you have understood what you've been teaching from the beginning to the end. Keep inviting other students to come and enjoy the beauty of probability and statistics. So stay tuned and enjoy the beauty of probability and statistics until we meet in the next lecture.